All right, in this video, we're going to talk about things that points that impact or influential points. And these are points that impact our slope or they impact our correlation, and they just impact the way the line looks. So we're going to talk about three different types of points, and we're going to call influential points. And we're high leverage, outliers, and then the combination. So let's take a look at a high leverage point. First off, a high leverage point, by the way, these are definitions that you need to know, far away from the mean, all right? And you're like, well, what's the mean? Well, it's the average of the x's and the average of the y's. So if my original graph was given by this red line here, you go, well, you know what? My average is about here. And I just eyeballed it. That'd be about the average of the x's and the average of the y's. A high leverage point would be far away from the mean, all right? So it's a long way away. And because this green point right here is a long way away, if I added this green point, I should back up. These are my original points, all right? So what was given here are my original points. I'm just gonna go ahead and circle those. But if I were to add this green point, that would be a high leverage point, and watch what it does to the slope of my line. It substantially impacts the slope of the line, and it also impacted the y-intercept because my y-intercept went lower. On the other hand, if I had added this brown point right here, it's also a high leverage point because this is a long way away from the x, my average of my x's and my y's. This right here would be the average of the x's and the average of the y's. And the bar just tells me it's the average. All right, so this is a long way away. I add this point and it impacts my slope and my y-intercept. So a high leverage is far away from the mean and impacts your slope and your y-intercept. An outlier, on the other hand, is close to the mean because once again, here's my original set of data. My original set of data was this. So there's my original set of data. And here would be my average, my x bar and my y bar. That'd be the average, because that's about right here in the center of all those data points. And by the way, your average will always lie on the line. An outlier is one that's close to the mean, but has a high residual, all right? Must have a high residual, which means it's a long way from the predicted line. When I look at this one right here, it's a long way from the predicted line. The same with the brown line, it's a long way from the predicted line. And as a result, they don't change the slope of the line a whole lot. They didn't change the slope of the line. Matter of fact, they stayed almost exactly the same plot, but they substantially reduce R and R squared. So really important to know that, and you go, I haven't talked about R squared yet. I know. So outliers, close to the mean of X, but have a high residual and substantially reduce the R and the R squared. And then you can have a combination point, all right? So once again, I'm going to circle my original data. My original data is right here. And with this, once again, my X bar and Y bar, the mean of my X's and the mean of my Y's are about here. But I have a point that's a long way away, all right? It's a long way from the mean of X. And since it's a long way, it's going to impact my slope and y-intercept. And it has a very high residual. So this has to have a high residual, means it has to be a long way from my predicted line. And my predicted line would have been somewhere down here. So this has a very high residual. So away from the mean and a high residual, all right? So the reasons, the combination, high leverage, far away from the mean. All right, far away from the mean, but not necessarily a large residual. Yeah, it has a decent sized residual, but it's not huge. Here, we're close to the mean, but have a large residual. And finally, a long way from the mean and with a very high residual. So the combination impacts the slope, the R, and the R squared. All right, thank you for watching, and we will talk about those definitions on the next video. See you then.